Hi everyone, we're Amita and Akhila, and for our 236 project, we worked on Clock GAN, Combined Loss and Curriculum Training GAN for text generation. Traditionally, GANs were not used for text generation because the generator output is discrete and it's hard to get end-to-end training. But there are techniques to overcome this, such as reinforcement learning techniques like policy gradient, which is what we have studied in this report. We've used an LSTM generator and CNN discriminator, and our dataset was first synthetic, which was sampled from a randomly initialized Oracle LSTM, and then real, which was IMDb movie reviews. We used a negative log likelihood to calculate our evaluation. This is a diagram of policy gradient and how it's used to backpropagate the loss from discriminator to the generator.
This is a graph which shows the analysis of our different baselines. The blue graph is the one using the CentiGAN, and we see that it converges to a lower loss compared to remaining techniques.
The first thing we did is incorporate curriculum training into CentiGAN, which is when we trained first on sequence length 1, then 2, up till 20. We see a decrease in the loss function from about 7.6 to about 6.5, and experimented with different number of epochs for pre-training the discriminator, but did not see much of a difference apart from increased stability for lower epochs.
The next thing we did was change the GAN objective to incorporate the MLE objective, as is done in the FlowGAN paper. The weightage given to MLE is controlled by a hyperparameter lambda. It appears from our experiments that CentiGAN does better than the hybrid loss function, but this is because the MLE objective tries to minimize the KL divergence, whereas we are evaluating on a variant of the inverse KL.
The next thing we did is combine the combined loss function with the curriculum training. Here we saw some real gains. We lowered the test loss from around 7.6 to 6.0.
Until now, we ran all our experiments on the synthetic dataset. Next thing we did was run it on the real dataset, which is the IMDb movie reviews. It takes over a week to train, but we have some examples from the CentiGAN. We noticed that the examples from the FlowGAN are longer, but yet they're coherent, like addictive but lazy cartoon that's ultimately forgettable.
Here are some bloopers that we got from our experiments. The left-hand side is CentiGAN and the right-hand side is FlowGAN. We found these pretty funny.
Monkey do.
In conclusion, we have several improvements upon CentiGAN. First, by incorporating curriculum training and then adding a combined loss function. We were able to drop the loss from 7.6 to under 6, and we've generated some interesting examples. We're currently running experiments on the real data set as well. In the future, we plan to evaluate these generated samples more rigorously. We are also hoping to extend this work to other datasets. Thank you.